So now we're gonna take a quick look at this circuit right there. So we got the LED lit up. It's lit up pretty much as well as it can till I press the button. Discharges the capacitor and cuts off all power to the LED. And when I release the button though, pretty much instantly the LED starts lighting up, but it fades up, you know, dim at first and gets brighter over time. Here's the schematic diagram for it. So we can discharge the capacitor right there, get 0 volts, turns the transistor off. Open the switch, and then the capacitor starts charging. Its voltage rises. It transfers that voltage over to the current setting resistor. Now, it doesn't need to provide power. It just wants to get a little bit of current flowing, so the transistor starts conducting better, and therefore more current will flow, and more current flows through the LED, it gets brighter. And again, to restart the process once the capacitor is charged, we just close the switch to discharge the capacitor. So now, zooming in on the schematic, that's all connected right there. I don't always put a dot. I'll put a little jump if they're not connected usually. So in any case, we have a diode that's parallel to the capacitor when I close the switch. So that allows it to discharge, but it will only discharge to about 0.6 volts, not all the way down to 0 volts. 0.6 volts is what it takes to almost get the transistor to start conducting right there. So that's why when we open the switch, right when the capacitor starts charging, then we already got 0.6 volts, and then, you know, because you got 0.6 volts less over here. So 0.6 volts there, 0 volts there. As the voltage rises there, all of a sudden it goes 0 up. And so pretty much right away, you start getting current through the transistor. So yeah, there's the setup on the actual board right there. We got the cathode to the switch, anode up one row to the capacitor and the resistors. So now, when it comes to how much current flows through here, we got 220 ohm resistor. The voltage across it, about 0.6 volts less than what is at the base, will be what sets how much current flows through the entire circuit over there, transistor and LED specifically. So in any case, we got a 0.6 volt drop there. We lose a little bit of voltage. Ultimately, we can get, you know, up to about 10 milliamps of current, you know, approximate right there. So we got 220 ohm resistor. If we want a little bit more current, we just pluck that resistor right there. This is a 150 ohm resistor. So again, you know, we're not getting the full 5 volt supply. Sorry, this kind of fell into view. And across the LED transistor and 220 ohm resistor. Not going to go way too much in detail. But in case, you know, a little bit lower value resistor, we get a little bit more maximum current. You know, pretty easy to adjust that. So now we're going to make another adjustment. I put 150 ohms there, so we get a little brighter LED. But in any case, when we close the switch, capacitor discharges, LED turns off. Open the switch, as the capacitor voltage rises, the LED gets brighter. Basic thing. Now, I got a 47K resistor right there, and the value of the capacitor also makes a difference. But with the 47K resistor, that LED gets brighter at that speed right there. Maybe that's twice as fast as you want. And so what we're going to do is take a 100,000 ohm resistor, so twice the resistance. It's going to take the capacitor about twice as long to charge right there. And now the fade up, you know, basically starting as soon as you release the button, but it's going to take about twice as long to get to the full LED brightness. So it's that easy to adjust the speed of it. And this isn't too bad of a fade time either, but I think it's a little too slow. So now really quickly, I want to talk about this resistor. Exact value doesn't really matter, but whatever the capacitor voltage is, we can discharge it to 0.6 volts because we got a diode there, making sure we stop at 0.6 volts. But in any case, whatever the voltage the capacitor is, it goes up as it charges, comes to the base there. And then that gets transferred to the emitter, but you lose about 0.6 volts. Again, that's why we got the diode. Goes across this resistor. Now, without this resistor there, the capacitor has the potential of providing too much current. And, you know, not dangerous because we got a resistor headed to ground. But ultimately, we just want the voltage set to this point. We want the transistor to provide the current through the collector, and thus the load, the LED. So that's all it's doing, making sure this current doesn't overpower that one, lowering the current there. And there's the actual circuit before I end this. So thanks for watching.